we have we have understood this question. Okay, we have understood. Now let's see second part. I would say second part of this question, where just we will replace this r by log r by log r. So we will have to calculate, or you can say find value of grad of log r. Okay, log r. Method will be same, formula will be same. Just in place of, just we will replace this r by log r. That's it. That's it. Second question. Second, grad r. Remember, r is a position vector. Okay, so here the symbol is not present, so that's why we can say r is equal to, this is the magnitude of a position vector. R is the magnitude of a position vector, so that's why we can write it as a x square plus y square plus z square, you know. And if, what will be value of r square, you know, x square, not x square, r square will be what, x square plus y square plus z square. Try to understand. But vector r, this will be equal to x I cap plus y j cap plus z cap. You can see these are three values of a different r. This simple r, which is without a square, which is without arrow, this is equal to under root of x square plus y square plus z square. How did it come? You know, r square, it is also magnitude of position vector, which is equal to x square plus y square plus z square. And we know that value of this position vector is equal to x I cap plus y j cap, where x is along I cap, y is along j cap, and z is along k cap. Okay, this was very important for this part and for the previous part. Okay, for the previous part. So it is saying you have to find grad of log r. Log r. You know that this will be equal to, d upon dx I cap plus d upon dy j cap plus d upon dz k cap into or 5 whenever grad is coming. Not direct question is saying find a grad dot log r. Question is saying, okay. Value of log r, in the place of r we can write what, this under root of x square plus y square plus z square. One thing more, this x square plus y square plus z square, this can be written as x square plus y square plus z square raised to power 1 upon 2. Okay, 1 upon 2. Is this clear? Clear? Is this clear? Tell me. If yes, then we can move forward. Look at one. So log, and value of this is how much? X square plus y square plus z square, which is raised to power 1 upon 2. 1 upon 2. So log x raised to power n is equal to 1 upon 2 log x. 1 upon 2 log x. Just substitute this value with the first term, with the second term, with the third term. Then see d upon dx. Look, d upon dx, we have log x square plus y square plus z square, which is raised to power 1 upon 2. I cap plus I cap plus d upon dy log x square plus y square plus z square, same 1 upon 2, then with this term d upon dx, and it is along z cap. This is along z cap. Z log x square plus y square plus z square, it is raised to power 1 upon 2. This is along k cap. Okay, this is along k cap. Now we are going to represent this log x n with respect to this dx. First of all, this will become 1 upon 2 log x. Then we will differentiate this x square by x. Am I correct? Yeah, you are correct. 1 upon 2. Look at it. This will come downward. 1 upon 2. 1 upon 2 d upon dx log x square plus y square plus z square. Got it. This is along I cap. Same with this will happen. 1 by 2 d upon dy log x square plus y square plus z square. Okay, just this 1 upon 2 will come down. Z cap plus 1 by 2 d upon dz log x square plus y square plus z square. This is along k cap. Okay, now let's differentiate this x square by dx. We will get what? 2x. We will get 2x. Okay, and then we will differentiate this log x. So log differentiation of log x is what? 1 upon x. Remember, log x is equal to 1 upon x. Okay, 3 times we differentiated it. First 1 upon 2, and second is this 1 upon x square plus y square plus z square. Then we will differentiate this dx square upon dx, which will be equal to 2x. So 1 upon 2, and this will be equal to 1 upon x square plus y square plus z square. Then 2x. Okay, no problem. This 2 will cut to each other. Am I correct? Same over here. 1 by 2 multiple 1 upon x square plus y square plus z square multiple 2y. This is along, it was along I cap, and this is along z cap. This is along z cap, plus 1 by 2 then multiplication 1 upon log x is equal to 1 upon x square plus y square plus z square. Okay, hold on. Depreciation of partial depreciation of z square with respect to dz will be 2z, which is along k cap. Okay. Okay, no problem. Here this 2 is cut into each other, this is also cut into each other. So finally we have x upon x square plus y square plus z square. Am I correct? Am I correct? Yeah, I am correct. Try to observe carefully. What term are you getting as common? What term? So you would say this 1 upon x square plus y square plus z square. This is present in each term. In this term, in this term, in this term. But x, y, z, these are different. So 1 upon x square, you can write 1 upon x square plus y square plus z square. This is common. And left things, this x I cap plus y z cap plus z k cap. Now tell me, this is equal to what? X square plus y square plus z square is equal to what? Here you can see this is equal to r square. Can you write this as r square? Yeah, but without having arrow. And this is a value of r vector, or you can say position vector. So dot of position vector. Am I correct? Finally, you can write it as a r vector upon r raised to power 2. And this is nothing but it is a grad of log r which is equal to del operator into log r, which is equal to position vector upon r square. This is our final answer. That is how you will solve. So gradient of log r will be equal to position vector upon r square, where log r is equal to log into x square plus y square plus z square raised to power 1 upon 2. Okay. Okay, next question. Let's see next question. Next is little bit different, not too much. Let me write first of all question number next. Prove that grad r in Rn is equal to n r raised to power n minus 2 into r vector, where r is the position vector. R is the position vector of any point. Okay, we have to prove that this grad of r raised to power n is equal to n r raised to power n minus 2 dot r vector, where r vector is the position vector of any point. Okay, so finally you can say this r is equal to x I cap plus y j cap plus z k cap. This is a components of a position vector. This is a components of a position vector. Okay, so write this over here. Write this over here. Let's prove. This r vector is a x I cap plus y j cap plus z k cap. This r can be written as x square plus y square plus z square. Okay, we have found a value of r which was compulsory for this. Okay, so we know that gradient of Rn will be equal to del operator dot Rn. We will use operator. Then we have value R, and just put n over here, n. So this will become n by 2. 1 by 2 will become n by 2, and then everything will be same. N by 2 will come downward. N by 2 will come downward. X square. Look at over here. We have to find grad Rn, which will be equal to d upon dx I cap plus d upon dy j cap plus d upon dz k cap. We have to multiply this by this value, which is x square plus y square plus z square raised to power n by 2. Raised to power n by 2. Just substitute this value in each term of this bracket. So this will become d upon dx x square plus y square plus z square n upon 2. This is along I cap plus d upon dy x square plus y square plus z square n by 2. This is along j cap plus d upon dy x square plus y square plus z square. This is raised to power n by 2. It is along k cap. This is along k cap. Okay, this is along k cap. Got it. Now look at over here. N raised to power x will be what? N by 2 will be n by 2 n by 2. N by 2 x square plus y square plus z square raised to power n by 2 minus 1. This is, and then dot what? 2x. Am I correct? 2x. Yeah. we are correct. I was getting confused. Okay, now this n by 2 will come downward, n by 2. This will be as it x square plus y square plus z square quoted, and this will become n by 2 minus 1. N by 2 minus 1. Same will happen with this third term. Third term is n by 2, and remember this is along I cap, this is along C cap. N by 2 x square plus y square plus z square, this is raised to power n by 2 minus 1, which is along K cap. Okay, K cap. Now you can see, brother, this 2 is cutting to each other. Same over here, and this will be 2y, this is cutting 2z, this is cutting to each other. Am I correct? Now we have this common thing, n and this wall is common, means you can write n x raised to power 2 plus y square z square n upon 2 minus 1. This is common, yeah, it is common. And we have x I cap plus y c cap plus z k cap. Am I correct? You can see this is value of r square and this is value of position vector. So finally you can replace this by r square and this by r vector. So n simplify this, n by 2 minus 1. What will you get as a result? This will be 2, this will be 2, 2n minus I think n minus 2, n minus 2, n minus 2, n minus 2. Look at over here. This is value of r square. R square. So n upon 2 minus 1. Okay. So you can write this as a n minus 2. n minus 2 upon 2. Okay. This is value of position vector. Dot. Now look at over here. This will go over it. So it will become r n minus 2 by 2 multiple by 2. This 2 will cut to each other, dot r vector. So finally we got this RHS. LHS is equal to RHS. n r raised to power n minus 2 dot position vector. This is RHS, hence proved. Okay, hence proved. Finally you can say gradient of Rn is equal to n r raised to power n minus 2 dot r vector. This is our answer. This is our answer. Okay. Now let's move towards the topic, which is a divergence. Divergence means something is diverging. Something is diverging. Okay, this is the meaning of something is aspirating out. Here something will be vector. Okay, vector is aspirating out. It means divergence of vector is not equal to 0. If it is equal to 0, you can say that vector is not aspirating out. Okay. If a divergence of any vector is equal to 0, then you can say vector is not aspirating out. Let me explain about more divergence. Divergence is very simple. If we want to convert a vector quantity to a scalar quantity, then we will find a divergence of a vector quantity. It means divergence of a vector quantity will give a scalar quantity. Divergence of a vector quantity will be equal to a scalar quantity. Okay. In the previous we were observing that gradient of I think a scalar gradient of a scalar was coming a scalar quantity. Result was coming as a vector quantity. Am I correct? Opposite. Divergence of a vector quantity will provide a scalar quantity. Gradient of a scalar quantity will provide a vector quantity. This is a fact. Okay. This is fact. Now, we use this divergence when if we want to convert vector quantity into a scalar quantity, then a vector quantity to a scalar quantity, we will find the divergence of a vector quantity That's why we use a divergence. Okay. Divergence is used to convert a vector quantity to a scalar quantity. Then we will find divergence of a vector quantity. So remember del operator, which is equal to d upon dx plus along I cap. Okay. D upon, since it is a vector, that's why phi j k will come. So this dy j cap plus d upon dz k cap. This is our del operator, which is a vector operator. If f is a vector quantity, if f is a vector quantity, in the previous question we were observing that phi was a scalar quantity. Yeah? Phi was a scalar point function. Now if f is a vector quantity, then its component will be fx I cap. Am I correct? Yes. Or you can say f1 f2 j cap plus f3 k cap. this is a components of a vector f. Okay, then our divergence dot f vector will be what? Just you will put this value with each term of this del operator. Am I correct? Yeah. So let's put d upon dx I cap plus d upon dy j cap plus d upon dz k cap into this f1 I cap plus f2 j cap plus f3 k cap. Since it is a dot product, yeah, so just substitute this value over here. We will get d upon dx f I cap. Look at over I will become I dot I is equal to 1, where theta is how much? I think 99, not 90, 0, okay, 0. So this I will become 1. This f1 plus f2 plus f3 plus f3. Am I correct? So this one f1 will come with this I cap f1 plus d upon dy. This f2 will come with the j cap. Then d upon dz, this f3 will come with this third term, which is f3. Are you crystal clear? This was very easy. Everything is the same except this quantity. In the previous question, here was what? A scalar, but here this is a vector quantity. Clear? We are using dot product. When it comes to gradient of any scalar quantity, we use the dot product. When it comes to divergence of any vector, we use what? Dot product. So remember, gradient dot product, divergence dot product, but when it comes to curve, then we use a cross product, right? So finally we got this thing which we will apply in upcoming question. Okay, in upcoming question, and you can write again. I am telling you, this del operator can be called as a divergence or gradient. So this is a divergence of f vector is equal to del operator into f vector. Clear? And this is equal to this much. Now let's take question so that we can get clarity. Look at over here. This is one question. If vector is equal to y I cap plus x square plus y square, it is along z cap plus y z plus zx, it is along k cap. Okay, this is a components of I think it is a value of a vector f, where f is a vector. Calculate what? Calculate divergence. Calculate the divergence of f, or you can say divergence of vector f. Okay, you have to find divergence of vector f where value of f vector is given. You know divergence, value of divergence is equal to how much? This much. Okay, now let's substitute value. Look at over here. This is given. I am writing directly. So div of f is equal to del operator dot f is equal to d upon dx, this first fi f1 plus d upon dy f2. Am I correct? I am writing directly. Plus d upon dz into f3. So we have in place of what f1, which is a y upon dx. In place of f2 we have x square plus y square upon dy plus f3 is how much? Yz plus zx, which is with respect to dz. Okay, now this will become 0. Reason is this is a partial differentiation. So partial differentiation of a y with respect to dx, both are different, that's why this will become 0. Okay, 0 plus dx square upon dy, again it will become 0, but differentiation, partial differentiation of y square with respect to dy, this will become 2y. I think x square should be as it. Okay, we will check. So over here, this will become y, and this will become x. Am I correct? This is our answer. 2y plus 3y plus x, and just put value of x and y, you will get exact value without having direction. Look at it. So x plus 3y, yes, this is the correct answer. So this is nothing but x plus 3y, this is nothing but divergence dot f is equal to, this is value of a divergence of a vector f, which is a 3y plus x, and if x, y are coordinates. Okay, x, y are coordinates. Now we will take next question. You can see we are getting only magnitude, so hence it is a proof, it is evidence that whenever we will diverge of any vector, we will get a scalar quantity. Whenever you are doing a gradient of any scalar quantity, then you will get vector quantity. Okay, it was fact, it is fact, it will be fact. Okay, let me write next question. This was first question based on divergence. Clear? What are you understanding by this number? You are understanding that this much is a diverging. What is a diverging? This f vector, this much. Okay, let's see next question. Next is, if I think now coordinates will be number. Coordinates will be a number. If a vector is equal to 3x square I cap plus 5xy square z cap plus xyz square k cap, then find divergence of a vector at what, at point. That point is in coordinates 1 comma 2 comma 3. These are coordinates. You know that a 1 is the value of x, 2 is the value of y, 3 is the value of z, 3 is the value of z. We have value of a vector, we have coordinates, and question is asking only divergence of a vector. This is very simple. Let's see what magnitude will be get. So first step is to write whatever is given. 3x square I cap plus 5x square xy square z cap plus xyz square k cap. This is given. At 1, 2, 3. So divergence of a vector is equal to del operator dot a. This is equal to you would say, or you can write like this. The value of del operator is what? D upon dx I cap plus d upon dy z cap plus d upon dz k cap dot of a. We have value which is 3x square I cap plus 5x y square z cap plus x y z square k cap. This is another method. Okay, another method. You can see we have dot product in this equation. So this I cap will become 1, and we will multiply this by this. So d upon dx, and this if a1 is how much? 3x square. Am I correct? 3x square. Then plus this j will become 1. So d upon dy into 5xy square. Then plus d upon dz into xyz square. Okay, z square. Here kk is becoming 1. Kk is becoming 1. Okay. So partial differentiation of 3x square will be, with respect to x, will be how much? You would say 6x. Okay. What about this? X will be as it. So this will become 2y. 5 to the 10. 10xy. Okay, 10xy. What about third term? Xy will be as it. Z square will become 2z. So you can say 2xyz. Now your work is to substitute value of x, y, z and then see what magnitude are you getting. This is nothing but at 1, 2, 3. Divergence dot a will be 6 multiple 1 plus 10 multiple 1 multiple 2 plus 2 multiple 1 multiple 2 multiple 3. This is 6, 10 to the 20, 3 to the 6, 6 to the 12. 20, 30, 38. This is our magnitude, which is a scalar quantity. Is a scalar quantity. Okay, this is our scalar quantity. So remember, divergence of any vector will always provide magnitude, not direction. Clear? Not direction. This was another method. We didn't found this directly from this. From this, how did it come? We wrote over here. I wrote over here. How did it come? This came from this. Okay. Let me write next question. Next question. This was a 38. It is correct answer. This is correct answer. Now next. Next we have next. Next question is, if a vector is equal to x square z I cap plus minus 2 y cube z square z cap plus x y square z k cap find divergence of a vector at this point, which is 1 comma minus 1 comma 1. At this point we have to find divergence of a vector where vector A is this much. Okay, is this much. Now in this question I will use direct that equation which we need. Okay, which we need. So let's solve. A is given, which is x square z I cap plus minus 2 y cube z square z cap plus x y square z k cap. Okay, at this point. So divergence of vector A is equal to del operator. This is what we know. So divergence of A vector is equal to d a1 upon dx d a2 dy plus d a3 upon dz. Till here we don't have any dots. So a1 is how much? X square z, and a2 is minus 2 y raised to power 3 z square, and a3 is x y raised to power 2 z. Okay, just substitute value. So x d x square z upon dx plus d minus 2 y cube z square upon dy plus d upon dz, and a3 is how much? X y square z. Okay, so a I cap, z cap, k cap will go. Here you can see partial differentiation of x square z with respect to dx will be 2xz. Am I correct? Yeah. What about this? Z square will be as it. So minus, this will become minus 2, I think 6y square z square. Okay, then plus x y square. Now this is at 1 comma minus 1 comma 1. At this point we have to find the divergence of vectoring. Divergence of vectoring. So just we will substitute value of x, which is 1, value of y, which is minus 1, value of z, which is 1. Okay, that's it, and your answer will come out. So divergence dot a is equal to 2 multiple 1 minus 6 multiple minus 1 raised to power 2 multiple 1 raised to power 2, then plus value of x is how much? 1, and value of y is minus 1 raised to power 2. Simplify it further, this will become to minus 6 plus, not plus, yes, plus 1 plus 1 plus 1. So finally we have this, which is equal to del operator dot a vector is equal to 3 minus 6, which will be minus 3. This is our magnitude, which is a scalar quantity. Remember, this is a scalar quantity. Clear? This is what question was asking. Divergence of a vector whose values were given, and the answer came out as a minus 3. Okay, minus 3. Now let me write next question. Hold on. Answer is not minus 3. Here we neglect this minus. We neglect this minus. Look at over here. Minus was already present over here. This minus. So here you will have to neglect this minus. So this 3 will be final answer. 6, yeah, everything is same. Now next question. Next question. Next question is, proof that divergence Rn and R vector is equal to 3 plus n raised to power dot Rn. This is LHS and it is RHS. How to prove it? Question is saying divergence of Rn R vector is equal to means this can be written as del operator into R in into R vector. Am I correct? Then we will put value of del operator and then value of Rn R, then value of R vector. R vector. Okay, value of R, then value of R vector, then value of del operator. Clear? Del operator. Then we will put H n by 2. Look at this question. It is asking prove that divergence of R n dot R n is equal to, it should be equal to 3 plus n dot R n. Let's prove. Let's prove. This is asking divergence R n R vector which is equal to 3 plus n dot R n. You know that this can be written as divergence R n can be written as del operator R n R vector. Am I correct? Both are equal. Just substitute value of this. So this d upon dx I cap plus d upon dy z cap plus d upon dz k cap. Clear? Clear. Dot. Value of R is how much? This is x square plus y square plus z square. Am I correct? And this is a raised to power n. Then dot. Again dot. Again dot. Value of a position vector is always I think x I cap plus y z cap plus z k cap. Am I correct? Z k cap. Just we substituted value of del operator, value of R vector. That's it. Now you know that this will be multiplied by x, this by y, this by z, where it is a dot product. Okay, it is a dot product. So finally you can say this dv upon dx will be equal to this will be equal to x square plus y square plus z square. It is equal to n by 2. Value of this root is 1 by 2. 1 by 2 multiple n will become n by 2. Will become n by 2. Okay. And then it is with, this is with x dot x. Am I correct? Let's suppose this is our first. Next, remember it is along I cap. But we are using divergence. We are talking about divergence. So that's why x, y, z, I, z, k will go. So over here this plus will come. Then d upon dy and this thing x square plus y square plus z square and this n by 2 and this is with a y. Am I correct? This is another plus d upon dy, this one which is x square plus y square plus z square raised to power n by 2. Okay, and this is with z dot z. This is a third. This is our third. Am I correct? So differentiation of this will become n upon 2 into x square plus y square plus z square into x. But again differentiation of x square will become 2x. Will become 2x. Am I correct? Yes or not? Yes. So finally you can say this will become n by 2 x square plus y square plus z square, and differentiation of x square will become 2x into x. Okay, crystal clear. Till here we are crystal clear. Plus differentiation of this will become n by 2 x square plus y square plus z square. Differentiation of y square will become 2y into 2 into y. This is our third term. Okay. What about this? Was the second term? No. Next is the third term. So differentiation of this will become same, x square plus y square plus z square into 2z and 2z. This is 2z. How did it come? It came from differentiation of z square. Hold on. This will become z. Okay, this will become z with respect to dz. From this it came. This is our third term. Okay, this is our third term. This 2 is cutting to each other. This 2 is cutting to each other. This 2 is cutting to each other. Hold on. Not this. This is z square. This 2 is cutting to each other. So we have x square, y square plus z square again. You can see n x square plus y square plus z square. This is x square. Am I correct? Plus n x square plus y square plus z square, it is equal to y square. Then we have n x square plus y square plus z square, which is equal to z square. Are we correct? In this equation we can say this is common, means n x square plus y square plus z square, this is common, and we left what? X square plus y square plus z square. Are we correct? Look at over here. This will be n upon 2 minus 1. N upon 2 minus 1. N upon 2 minus 1. Same over here. N upon 2 minus 1. And n upon 2 minus 1 is equal to 2 n minus 2. N minus 1 upon 2 n upon 2 minus 1. So this will become n 2 minus 1. This is common and everything is same. Everything is same.